This video is going to be a continuation of the first one, which is 2-1 quadratic function. This is the notes that we did in class. Now we stopped at number 4 in the first video, so we're going to continue from number 4. By looking at number 4, I can directly tell that it's x minus 2, so it's going to shift not to the left but 2 steps to the right. Since there is parentheses, so the change is going to be done to the x. So I start with the table of the parent function, which is negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. I create a new column next to the x, and instead of x minus 2, I put x plus 2. Remember, every time there's parentheses, it's opposite, and the change is going to be done to the x. So negative 2 plus 2 is going to be 0, negative 1 plus 2 is going to be 1, 0 plus 2 is going to be 2, 1 plus 2 is going to be 3, and 2 plus 2 is going to be 4. So my new coordinates are going to be 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. Let's plot those points, and my graph, if it's right, it should move to the right. So 0, 1, 2, 3, 4. So this is the point. 1, 1, 2, 0, 3, 1, 4, 4. This is my new parabola, as you can see, by comparing it to the parent function, which is going to be somewhere over here. Let me draw it in blue. So compare it, as you can see, it did move 2 steps to the right. So yes, my graph is right. Now let's do the domain and range of my red graph. As you can see, it's going to extend forever, so the domain is going to be negative infinity to infinity. The domain, it starts from the bottom point, which is 0, up till infinity. As you can see, the domain of every single one that we have done so far is negative infinity to infinity. So x can be any real number. Anything that you can think of will work for a quadratic function. Now let's look at this one over here. Let's review. Parentheses, so change done to the x, opposite to what you see, so it's going to be x minus 2 and x plus 2. You create a new column next to the x plus 2. A negative, again, no parentheses, so the change is going to be done to the y, so it's going to be a new column that's negative y next to the one to page 2. X squared plus 2. There's no parentheses, so this change is going to be done to the y. So I start with my parent function, negative 2, 4. As you can see, it's always the same table, which is the table of the parent function. Now plus 2, so the change is going to be done to the y since I have no parentheses, and it's exactly like you see, so it's y plus 2. So it's going to be 6, 3, 2, 3, and 6. My new coordinates, the x did not change, it's the same thing. So the new coordinates are negative 2, 6, negative 1, 3, 0, 2. Now what you can do is you can try to graph this and graph both of them, the parent function, which is y equals x squared, and this function, which is y equals x squared plus 2, graph it on your calculator and to check your work. Now, but my pre-AP, you cannot do that. You can do that at home, but you cannot do that in class, because on the test you're not allowed to use a calculator. So this is my new function. As you can see, comparing it to the parent function, as you can see, the parent function is usually starts at 0, 0, so it did move 2 steps up. So every time you see x squared plus 2, you're going to know that your shift is going to be 2 steps up. If you have parentheses, it means it's going to either go right or left. If you have no parentheses, the change is done to the y, so it's either going to go up or down. Now, the domain is going to be, as you can see, it's going to extend on forever. So the domain is negative infinity to infinity. It's also the same for every single one. The range is the bottom point. In this case, it's the 2, all the way to plus infinity. Now let's move on to number 6. No parentheses, so the change is done to the y, and it's exactly the same as you are used to. So it's exactly the same. So the shift is going to be 2 steps down. There's no parentheses, so the change is going to be done to the y, so it's either up or down. So shift 2 steps down. Again, you start with the table of the parent function, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. You create a new column next to the y, and it's exactly as you see it, minus 2. So 4 minus 2 is 2, 1 minus 2 is negative 1, minus 2, negative 1, and 4 minus 2 is going to be 2. So these are my new coordinates, and they are negative 2, 2, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, 2. Let's plot those points. Negative 2, 2, negative 1, negative 1, erase that, 0, negative 2, 1, negative 1, and 2, 2. So this is going to be my new function. As you can see, so it's going to be a point over here. So this is my new function. As you can see, it did move 2 steps down. So the shift is 2 steps down. Now the domain is going to be negative infinity to infinity. We should know that by now. The quadratic function, the domain of the quadratic function is always negative infinity, infinity. The range is from the bottom point all the way up, since it's extend forever. So it's going to be negative 2 to plus infinity. That's the range. This is for number 6. Let's summarize. You have no parentheses, so the change is going to be done to the y. And it's exactly as you see it. So y plus 2 and y minus 2. The change is done to the y, so it's going to either go up or go down. Plus 2 means it's going to go up. Minus 2 means it's going to go down. Number 7 and 8. Let's look at number 7. Now it's 2x squared, which means 2 times x squared. So what does it mean? There's no x, there's no parentheses, so the change is not done to the x, the change is done to the y, and as always, you always start with the table of the parent function. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now, you create a new column next to the y, and since it's 2 times x squared, so it's going to be 2y. You multiply the y by 2, so 4 times 2 is 8. 1 times 2 is 2, 0 times 2 is 0, and so on. So my new coordinates are this one and this one, which is negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 8. Let's graph it. So negative 2, 8. Going to be somewhere over here. Negative 1, 2. 0, 0, 1, 2, and 2, 8. So this is going to be my new graph. As you can see, if you try to draw it on the calculator and compare the y1 to y2, which is the y1 is the x squared and the y2 is the 2x squared, you're going to see that this one is going to be thinner than my parent function. So every time you see a number being multiplied by x squared, it means that this function is going to be vertically stretched or vertically compressed. Since you are multiplying by a 2, which is a number greater than 1, so we call this a vertical stretch. by a factor of 2. So every time you are multiplying x squared by a number, or there's a number that you are multiplying by, it's either a vertical stretch or a vertical compress. If you are multiplying by a number greater than 1, that's a vertical stretch. And when you look at the graph and compare it to the main graph, it's going to be thinner. Now let's look at 8. Again, there is a number which is half, and you're multiplying half by your function. So this is going to be a vertical, not stretch this time, it's a compress. And the reason it's a compress, it's because half is less than 1. So it's a vertical compress by a factor of half. So if you are multiplying by a number that's greater than 1, it's a vertical stretch. Every time you're multiplying by a number that's less than 1, it's a vertical compress. What does it mean for the graph? Let's go ahead and create our table. Always start with the parent table. And again, there's no parentheses, so the change is done to the y, and this is going to be half y, exactly like you see it, half times y. So 4 times half, basically you're dividing by 2, so 2, 0.5, 0, 0.5, and 2. These are your new coordinates. So the new coordinates, I'm going to write them over here. They're going to be negative 2, 2, negative 1, 0.5, 0, 0, 1, 0.5, and 2, 2. Let's grab those points. Negative 1 half, 0, 0, 1 half, and 2, 2. Now let's connect those points and look at this graph. Use your calculator. On y1 put y equals x squared, and on y2 put half x squared, and you're going to see that your new function is going to be wider than the parent function. So a vertical compress means you're going to see a wider graph. A vertical stretch means you're going to see a thinner graph. So that's it. That's everything you need to know on transformation. And if you think that there's something that you don't understand, it's okay, because we're going to do the same thing with all of the other functions. So let's summarize. What effect on the graph of the quadratic parent function does each one do? Remember, f of x equals to negative x squared means it's going to be a reflection across the x-axis. X plus h squared, remember, inside parentheses, so it's opposite to what you see it. If it's x plus 2, it means on the table you put x minus 2, and this means that it's a shift at h steps, remember, depending on the number, so h steps to the left. So again, inside the parentheses means either to the right or to the left. Here's going to be a shift of h steps to the right. There's no parentheses, so it's going to be either up or down. So this is going to be a shift as you see it, plus k, so shift k steps. So if it's x squared plus 1, it's going to be 1 step up. X squared minus k means it's a shift. Let's say if it's x squared minus 2, it would be 2 steps down. So k steps down. Now every time you're multiplying by a number, it depends on the number. For example, if you're multiplying by 3, it means that it's going to be a vertical stretch by a factor of 3. If you're going to be multiplying by 1/3, as you can see, it's a number less than 1, so it's going to be a vertical compress, which means every time you graph it, it's going to be a wider graph by a factor of 1/3. That's a summary of everything that we learned in 1. So let's move on. Number 1, quadratic function, and this is a practice. This is going to be your homework. They want you to graph this one. as you can see, there's multiple of things happening. We have the negative, we have a parentheses x minus 3, and we have plus 1. So there are three things happening. Remember, what does the negative 1 mean? What does x minus 3 mean? What does plus 1 mean? Remember, you always start with the parent function. I'm not going to continue it. And a minus over here means that the y is becoming a negative. So you create a new column and you put minus 1. So this is going to be negative 4, negative 1, and 0. Negative 4. Now, the plus 1 over here means you're adding 1, so you create another column, and this new one is going to be y plus 1. So now this does not exist. This is the new y that you're going to be working with now to add a 1 to it. So every time there's multiple steps, you do one at a time. Let's do the negative first and the plus 1 next, because both of those have to do with the y. First of all, the y become an opposite, so negative y, and then you're adding 1 to this new y. So negative 4 plus 1 is going to be negative 3, negative 1 plus 1 is 0, and 0 plus 1 is 1. So this is your new y, and there's no other change done to the y, because this one over here is to the x. So create a new column next to the x. And remember, every time you're making a change to the x, it's opposite to what you see. So since it's x minus 3, so it's going to be x plus 3. How can you tell if the change is done to the x or to the y? Again, if there's parentheses, it means the change is done to the x. Anything outside the parentheses, the change is done to the y, and you do it in order from left to right. So x minus 3. Minus 2 plus 3 is 1. Negative 1 plus 3 is 2, and 0 plus 3 is 3. So this is your new x. So this is your new x, and this is your new y. So my new coordinates are 1, negative 3, 2, 0, and 3, 1. Again, you can continue all the other numbers, like you can put 1, 1, 2, 4 to get more points, and I want you to do that on your homework. This is just to help, remember? So now go ahead and graph your new, and let me know what happens. Now remember, if it's a negative, then it's a reflection across the x-axis. Over here it tells me it's going to go 3 steps to the right, and this one tells me it's going to go 1 step to the up, 1 step up. Put this on your calculator, y2 equals to negative, into parentheses x minus 3 squared plus 1, and on y1 put y equals x squared, so you can see if whatever you came up with is right or wrong. Now for the next one, as you can see, there's an f. This f means the function, which is this one. So basically it's the same thing as saying 2 into x plus 4 squared minus 2. So the function is telling you over here that you have to use this function, which is x squared. So instead of f, you can put the parentheses and put a square over here, just like I did over here. Again, you do exactly the same. You create a table starting with a parent function. You start from left to right. This is going to be a change done to the y, a change done to the y. So first of all, you create a column for the y and show me what this does. Then create another column for the y also with a negative 2. This one is a change done to the x, and it's opposite to what you see, so it's going to be a column next to the x, and you put x plus 4. You're going to come up with new points and graph those points. Now let's move on. Now I'm going to do number 6 with you. Reflect across the x-axis, it means there should be a negative. Stretch by a factor of 2. Remember, stretch means you have to multiply, and multiply by 2. Shift 2 units to the right. Since you're going right or left, it means this is a change done to the x. It's opposite to what you see. So shift 2 units to the right. So this is going to be a minus 2. 3 units up, so this is going to be a plus 3. So the function is going to have a negative. Stretch by 2, so 2, and then you have parentheses. Shift by 2 units to the right, so inside the parentheses I have x minus 2, I have square over here, don't forget the square, this is a quadratic function, and then you add 3 over here. That is going to be my new function. Now, over here, now remember the function is going to be, let me draw, if it helps you to draw the parent function, go ahead and do it. So it's going to be negative 1, 1, 1, 1, it's going to be 2, 4, and negative 2, 4. So this is my parent function. Now compare it and look. It's going to go 1, 2, 3, 4 steps to the right. Remember, we're comparing this point to this point to tell how they're moving. So as you can see, it's moving 4 steps to the right. So there's going to be an x minus 4 in the parentheses. Then it went 3 steps up, so it's going to be x plus 3. There's no stretch or compress. They look exactly the same, the exact same, let's say, width. So it didn't go thinner or wider. So this is going to be my function then. Now I think this is enough help for the homework. Please continue the rest, and if you have any questions, ask me in class.